All right, now we're going to use multiple angle formulas and the binomial theorem to prove that sine cubed of x is equal to 1/4 times 3 sine of x minus sine of 3x. And when they're asking us to use these multiple angle formulas, we can use our new definition here. So cos of n theta is z to the n plus z to the negative n over 2, and sine of n theta is z to the n minus z to the negative n over 2i. Let's start with our left-hand side. That says sine cubed of x is obviously sine of x all cubed, and I know that sine of nx is going to be z minus z to the negative 1 over 2i, and in this case n is 1, so that I can write this as z minus, hang on, sorry, I'm thinking ahead of myself, z to the n, z to the negative n. Z is 1, so z minus z to the negative 1 over 2i all cubed. And so I could write that as z minus z to the negative 1 cubed over 8i cubed. And to expand that, I'm going to use Pascal's triangle and 1, 3, 3, 1. So that gives me z cubed plus z squared times negative z to the negative 1 times 3 plus z times negative z to the negative 1 squared times 3 plus negative z to the negative 1 cubed all over 8i cubed, and I can tidy that up to z cubed minus 3z, so 1 over z squared, so plus 3 over z minus 1 over z cubed all over 8i cubed. Now, I guess because we're using these identities, let's make our positive indices negative so that we can collect the cubed minus 3z plus 3z to the negative 1 minus z to the negative 3 over 8i cubed. And hopefully you can see I've got a z to the negative 3 and a z to the positive 3 and a z to the positive 1 and z to the negative 1. So hopefully that means that I can work something out to be able to make it look like I want it to. So let's collect those. So I've got z cubed minus z to the negative cubed, and I can have minus 3z minus 3z to the negative 1 over 8i cubed. Now, to get it back into our other form, remember that I needed to have a 2i. So, well, I cubed is just negative I, right? So I could write that as z cubed minus z to the negative 3 over negative 8i. And over here I could have 3z minus 3z to the negative 1 over negative 8i. And I'm going to need to shrink this because I'm running out of space. And all right, so let me take 1/4 out of both of those so that I can have negative a quarter times z cubed minus z to the negative 3 over 2I. And I'm going to take out a negative a quarter there. So I'm going to, and I'm actually at the same time just going to factorize out that 3 because I don't really want it there with that. So plus 3/4 z minus z to the negative 1 over 2I. All right, well, I know that z to the negative 3 minus z to the negative 3 over 2I is equal to sine of 3 theta. So that's negative a quarter sine of 3 theta plus 3/4 sine of theta. And if I have a look at what I'm trying to prove, well, that's kind of what I'm looking for. I know I've got thetas instead of x's. So I can say that's equal to 3/4 sine of theta minus a quarter sine of 3 theta. I can take a quarter out over there. So therefore, I can say it's equal to a quarter 3 sine of x minus sine of 3x, which is equal to my right-hand side. So I can say, therefore, sine cubed of x is equal to a quarter times 3 sine of x minus sine of 3x.